Hello everyone. I am Dr. Kala Ku, Assistant Professor, School of Computer Applications, Lovely Professional University, Punjab. Now I am going to present one of my recent research work titled Deep Learning Model of Sequential Image Classifier for Crop Disease Detection in Plantain Tree Cultivation. Plantain trees are one of the most popular fruit crops all over the world, and banana is one of the most marketable fruits. Especially in developing countries, bananas are their part of daily life. They are taking the bananas because of its rich nutrient contents. And there are various diseases will affect the quantity and quality of the food crops. The diseases such as black sigatoka, yellow sigatoka, Panama, Bungy top, all these diseases are found very common in the banana plantations, and the farmers are facing very difficulty regarding these diseases. They couldn't able to identify these diseases with the direct eyesight. Sometimes that will be at the beginning stage itself they couldn't identified, and for because of these rapid and novel approaches are needed in this research work. We are combining the CNN and RNN techniques for disease classification and detection. Our aim is the early detection of the diseases. The main objective of the research work is to create a deep learning model for disease classification and its early prediction to support the farmers in plantain tree cultivation. As part of this, a new sequential image classification model is proposed to detect the diseases by combining RNN and CNN, which is named as Gated Recurrent Convolutional Neural Network. Recently, various techniques are proposed in the area of disease identification, pest identification in various plants such as tomato, beans, rice, and some common techniques too. And but the thing is that most of these techniques are based on these convolutional neural networks for image classification, and some variations of the CNN such as lightweight attention based networks and transfer learning based networks, compressed CNNs. In that way, the variations of CNN are used for this purpose. But in our proposed model, we are focusing on image series classification. For it helps to the detection of diseases at early stages itself by analyzing the growth series of plants. Plants we can identify the chances of diseases at the early stages itself. These are the main advantages of our proposing model. The proposed model classify the crop image sequences. For this purpose, a combination of CNN and RNN is used. For analyzing the spatial correlation between the input image pixels is carried out by the convolutional layers of the model, and uh, the high level features for learning the time dependencies between the image samples at irregular times are carried doing by using the recurrent layers. This research work has mainly three phases. First phase is pre-processing, and then we are going to the proposed model, and we are experimenting with the collected data set. Our input is the sequences of images that are periodically collected through a camera placed in the plantain tree cultivation land. In our dataset have sequences of images of various diseases as well as healthy plants. By analyzing our aim is to analyzing these series and identify the chance of the diseases that may occur in the future. So that's why we are analyzing the sequences. So at the early stage itself, any changes in the image, with any changes, early stage changes itself, we can predict the disease. that helps to identify the tendency of the plant to come under the particular disease class at the early stages itself. As part of the pre-processing stage, we are converting the images of these sequences into a uniform size of 21 by 21 pixels, and we are converting the RGB images to HSV format because RGB's images are somewhat noisier and image intensity separation will be difficult. That's why we are converting the format of the images of our dataset into HSV format. This is the architecture of the proposed gated recurrent convolutional neural network. It consists of fully connected layers, convolutional layers, pooling layers, batch renormalization layer, and recurrent layers. The fully connected layer is used to change the representation of high-level representation of the images into the low-level representations. The convolutional layers is applied convolution operation along these representations, and pooling layer is used for dimensionality reduction purpose, and batch renormalizations helps to avoid vanishing and exploding gradient problems while training, and recurrent layer is used for identifying the sequential patterns from these image series. Here we are using the disease image series. So based on analyzing the sequential pattern, we can predict what next. For that purpose, we are using recurrent layers. Here we are using gated recurrent unit as our recurrent layer architecture. Then the next, this is the working sequence. First, our output is 21 into 21 into 21 into NW size, and at the end we are getting a 7 number of classes. That is our we are considering 6 diseases and 1 healthy class images. This is our flow of data through our architecture. Then our data set. While moving to the data set description, our data set consists of the first table represents our description of statistics of the data set. Our data set consists of first class is healthy plant that consists of 948 images, and the next one is BXW, it consists of 731 images, and BBTD that consists of 902 images, and in a total of 4627 images are there. And we are using back propagation through time and gradient descent algorithm are used for training purposes, and we are using the metrics, evaluation metrics, recall and accuracy for evaluating the performance, and for comparing the results we are initially setting the parameters the same for every models. That is, optimization algorithm is IMS grade, loss function is cross entropy, learning rate is 5.10 raised to -4, batch size is 256, and iterations is 30,000. And the experimental environment is that Intel G78750 3.3 GHz, NVIDIA graphics card, and 8 GB RAM, Python 3.6 is used, and TensorFlow 2.0 is used, and Keras 2.2.4 is used for experimentation uses. The proposed model is comparing with the normal convolutional neural network, VGG16 network, and LANET based on the training accuracy and testing accuracy. This is a graph which shows the first one is representing training accuracy comparison between the different models. Here orange one, the first one represents our proposed model. From the figure it is clear that the accuracy is high for the proposed model. The second one is testing accuracy comparison. Here also we can see that gated recurrent convolutional neural network achieve high testing accuracy while comparing with the other models. And next we are comparing our results with in terms of recall value. Here also we can see our recurrent convolutional neural network achieves high recall value. It simplifies the correct classification of the disease in terms of recall. These are the confusion matrices for comparing the comparing the performance of classification in terms of predicted level and true level of various models. That is, our proposed model is the first one, and the second one is the convolutional neural network, and third one is VGG16, and the last one is LearnIt. By analyzing the values, we can analyze that the performance of proposed model is high in terms of while classifying BXW class, it achieves 100% accuracy, and while BBTD it is 0.98, that is 98%, and in the case of black sigatoka it is 90%, and in the types of healthy plants it is 83, and in the case of yellow sigatoka it is 97%. That is, it shows that by analyzing the results, it is clear that it is the accuracy is directly related with the number of images. If the number of images are high, the accuracy we are also getting high. That is one common thing we can find during our experimentation side. And we are going to conclude our model. Here our model helps to identify the diseases at the early stages itself, and we are incorporating CNN and RNN. CNN is for spatial analysis, spatial image processing, and RNN is for our time sequential classifier, as a part of sequential classifier for analyzing the sequential characteristics. Currently our model work on well on real world image sequences, and the thing is that currently we didn't fine tune the model based on the previous set hyperparameters. We experimented and compared the results. The next thing is that we can improve the performance by fine tuning the networks. And the one of the other problem we found is that currently we are manually are taking the pictures and arranging the sequence because WSN facilities were not available. The next thing is we are going to place a wireless sensor network and digital cameras in the plantation itself and collecting the data set. We hope that will help us to achieve more good data sequences. That's our future plan. Thank you everyone for giving this great opportunity for me. Thank you.